Welcome back to another video, guys. This one's going to be a little bit different. I have a Raspberry Pi here that I've modded quite a bit, and I'm going to 3D print a case for it, and I wanted to sort of walk you guys through the process that I use when I'm modeling these things that I'm going to 3D print. I've said in the past several times that I want this channel to be, mostly just gaming and relaxing, but definitely with some sort of like edge on let's just go make something. So yeah, here we are. This is kind of going to be the first video based on that. I have no idea what this is actually going to be about. Like, I know what it's going to be about and I know I'm going to do it, but as far as like editing goes and how in depth we're going to get, I'm not really sure. It's certainly not going to be like a tutorial on how to do this kind of stuff. And it's going to be more than just like what you see on TikTok where the dude puts a time lapse together and you see the end product and the end thing is 30 seconds. I think we've already gone over that budget. So I don't know, somewhere in there. But the goal is that it should be enjoyable, that even if you're not an engineer and you're just kind of like vaguely curious as to how this stuff works, or especially like how someone would just make these things at home without the normal equipment and pipelines that most companies have, then this should definitely be entertaining enough and slightly educational for you. And on the flip side, like if you're an engineer that just wants to see and critique my process and maybe get some inspiration as to how to do things differently or to, get those creative juices flowing at home, then you should also be able to get something out of this as well. So somewhere in there is the balance I'm going to try to strike. And yeah, especially with these kinds of videos, I've had a number of people approach me recently about, hey, I want to get a 3D printer, but I suck at modeling and I'm just not good at it. And, could you help me model this or 3D print this off? And what they don't realize is that, especially if you're making a functional part, being a modeler is really not much of a requirement. It's pretty much just, hey, can you measure things and type numbers into a computer accurately? And that's pretty much all it comes down to. And as you'll find today, even that's a bit of a stretch because like I have this wonderful device, which is a digital caliper. You just open it and it literally tells you how big the opening is. So if you needed to measure something, you just go boop and stick it on there and you're done. Kind of takes care of a lot of that for you. And then on the flip side, like a lot of the parts that I'm using today already have published schematics. So at that point, you're not even measuring anything. You're just looking for which lines have which numbers and you punch them into the computer and make it happen. So yeah. Okay, so this is Fusion 360. This is going to be the software that we're going to use to actually model the part that we're going to make. And yeah, there are definitely other like free pieces of software. I'm sure they all have their pros and cons. I've played with a few of them. Fusion 360 is the one that just feels the most intuitive to me. So that's the one we're going to use. There is a hobbyist version that is free. You have to renew the free license every year, but it's always free. I'm going to throw a link in the description to that because it's a little bit hard to find, but yeah, I really like this software. And then from there, the only other two things we're really going to need is this is the schematic for the LCD, and this is the schematic for a Raspberry Pi 4. So just for reference for you guys, this is the board that we're going to be using. So it's a Raspberry Pi 4. I cut the USB 2.0 off because we don't need it, and I've got some alternative power wiring down there. This just allows it to supply more voltage through, or more amperage through the USB. And we're going to need to basically build a case that fits through those 4 mounting holes and mounts this power distribution circuit on the side and hopefully the LCD on the top. So that's the goal. I don't know how much we're going to get through in this video. I'm probably going to do just the Raspberry Pi in this video, and then we'll figure out the other 2 mounts in a later video. But yeah, again, this is kind of just exploring. It's partly for me to explore the space of how is a YouTube video like this even going to work? How could I potentially stream this in the future? As well as hopefully whetting your guys' appetite to see more things like this. So yeah, let's get started. Big thing to note, I am going to lay this out in such a way that the x-axis and the y-axis kind of match the image that we were seeing online. So I'm going to grab the top, move that around. X-axis grows off to the right, y-axis grows up, and that's exactly how this image is laid out. So to start with, I usually like to model the actual Raspberry Pi board because that'll help us kind of have that situational awareness of where it's actually going to live. and we can kind of see how it's going to overlay into the case. And the goal is to basically build just a flat bottom structure with 4 pinch clips that the Raspberry Pi can mount into. So we're going to start again by modeling this board, which is basically just a rectangle with slightly rounded corners. And we're going to see just how easy those rounded corners are. So in this case, we have an 85 millimeter by 56 millimeter rectangle. So we'll come over here to Fusion 360 and punch that in. We're going to do that by creating a sketch. Sketches are kind of the core piece to all of this, because you always start by drawing out the 2-dimensional shape that you're working with, and then you perform operations or really tell the program how to take that 2-dimensional shape and make it 3D. So in this case, we're going to be drawing a rectangle, rounding the corners, throwing the holes in it, and then we're going to be doing a thing called an extrusion, which basically takes a flat piece or a flat surface and just gives it some thickness. And yeah, it's pretty easy. So we said 85 by 56. So now we can grab the fillet tool and round those corners out. And it tells us that the corner radius is 3 millimeters, which conveniently is the only spot in the entire diagram where they list millimeters. But I don't know, it's not going to be feet. That would be a big board. Inches would also be huge. So it's millimeters. I've decided 3.0. Fillet tool, and we can click on that dude, type in 3, and then from here it's just a matter of clicking 3, click 3, click, and 3. That wasn't that bad at all. So now we need to lay out where the 4 holes on the board are going to go, and exactly what the dimensions of those holes are going to be. Flipping back to our diagram, this has all the information we need and a whole lot more that we don't. But the good news is we can ignore pretty much everything on the inside of the actual drawing, because we don't care about any of that. We just are focusing on these 4 holes. And if we look down here and up there, here's the one that actually labels. So this one is 2.7 millimeters in diameter, and none of the others are labeled, and just looking at them, they're going to be the same. And now it's just a matter of spacing. And if we look off on the top right here, it tells us that the distance between this mounting hole and that mounting hole is 58 millimeters. And from here to that one is going to be 49. We know they're a rectangle, so that works well. So if we can place any one of them, we can place the other 3. And down here, this one is 3.5 millimeters offset this way. As you can see, they've got the vertical lines from that side to the center as being 3.5, and then from the base to the center is also labeled as 3.5. So 3.5 millimeters right, 3.5 millimeters up, and you've got the center of this hole, and then the other 3 can be laid out based off of it. So 3.5 millimeters that way, 3.5 millimeters up, and that's going to be the center of our 2.7 millimeter hole, which visually looks like it's about in the right place. That inner hole is what we're going for. The outer hole is actually, or the outer ring is the pad that you theoretically could, there's no solder pad on that, but it's, if you look, it's the spot on the board where they actually have like cut out. I don't know. I guess they just guaranteed that there's no components there. You could put a screw head or something there. But yeah, so 49 millimeters up is going to be the next hole. And then 58 off to the right. So again, the best way we're going to do this is grab a line, grab the center, and go 49 all the way up. 2.7, and then another line over. That's 58. And now here's going to be an interesting thing, is we should be able to take a line and drop it down off of that guy. And then we'll be able to actually tell Fusion that this line needs to be the same as that line, and it'll make them the same. But the big thing is now it will like forever enforce that they're the same, which is pretty convenient, because later on we can actually come back into this sketch and edit the dimensions if any of them are wrong, and then play all of our operations forward again. And in that way we can like edit the length of this line, and it'll forcibly make this line change and then play everything else back on top of it, which is really convenient. So 2.7, and finish sketch. There is pretty much the footprint of our Raspberry Pi board. So before we get too far, I'm going to save the changes, and we're going to call this the Raspberry Pi custom case. And we're going to save that into the default project because I don't have anything better. Saved. Thank you for showing me my web browser, but that works. Okay, so we've got the footprint and the sketch laid out. So from here, let's see here. I'm going to extrude the Raspberry Pi, and we need to figure out how thick we want this to be. So I'm going to grab my set of digital calipers. I'm just going to measure the thickness of the PCB that it's sitting on. Calipers say 1.5 millimeters. I'm going to call it 2 millimeters just to give us tolerance based on the stuff that we're going to be doing with it later. There's a 2 millimeter thick PCB, and we can come over here and actually rename this dude to Raspberry Pi. Furthermore, to make this stand out, we can give it an appearance. Perfect. Perfect. Getting there. So now I'm going to move this dude, and we need to figure out how far up we're going to move him, because after this we're actually going to make the footprint for the case and then throw in the actual pinch clips. Let's move him up. I think I want the actual footing of the case to be 5 millimeters, and then a 5 millimeter gap, and then the base of the board. So let's move him up 10 millimeters. And let's get started on building the footprint for the case. So I'm going to hide him. We're going to make another sketch. That's again just going to be flat. And I'm going to start off with the same 85 by 56 millimeter footprint. We're not going to worry about rounding the corners. It's going to end up having to be bigger, but we can always adjust it and make it bigger later. So we've got that. That's really all we need for now, because we're going to extrude the actual pinch clips up out of this guy. So we're going to hit finish sketch. So like we said, case is going to be 5 millimeters thick. Easy day. And then Raspberry Pi is going to float a little bit off of that, and we just may need to make the pinch clips that actually fit into the holes. And that's it. So the best way that I know of to do that is we're going to re-enable the Raspberry Pi footprint. And this is going to be where it gets pretty cool, because by re-enabling the Raspberry Pi footprint, we can actually just reuse these circles that literally came from the Raspberry Pi, and we can just extrude them back up so that we know that the case is going to fit into it. So we can hit extrude. So yeah, we're going to reuse the actual holes that we drew in the sketch just to make sure that they line up completely with the Raspberry Pi itself. So if you notice, this won't let us select through the surface that we've already made, but if you click and hold, it'll actually let you select that profile, and that profile, that profile, and that one, that profile, that one, and that guy. Now the question becomes, how far do we want to extrude them up? 12 gets us to the top of that guy. 15 is another 3 on top of that, but the plan is to have a 1 millimeter guide and a 1 millimeter thick guide on the top and bottom to actually hold it in place. So if that ends at 12, that's only 2 millimeters between the top of the guide and the top of that. So I'm going to give us one more, and we can tell Fusion that, hey, we're actually looking to join the results. And when we do that, we get those nice little pegs. Oh, no, but we didn't quite want to join it like that, because we don't want to join it to the case. We want to join it to, or we do want to join it to the case, but not the Raspberry Pi itself. And then from here, once again, we have +1, +3, and then that looks right. We can hide the Raspberry Pi itself, tell Fusion that we want to do the join, and hit OK. And then re-overlay that guy back on top, hide the footprint again, and we're off to a really good start, actually. So from here, really all we've got to do is model the little pinchy part to the pinch clip. which is, in case you were wondering, the technical term for that. So I think, and I'm trying to figure out the best way to do this. I'd like to design the side profile that kind of protrudes off of the side of the cylinder, and then we can just revolve it around the cylinder. And then we just need the plane through 3 points, which is going to be 1, 2, and 3. And we're good. So there is the surface that we're going to sketch on. So when we hit create sketch, we can now select the plane we just made and actually sketch out the profile for the pinch clip, which is pretty much just going to be this sort of thing. We're going to want it 1 millimeter thick, I know that much. And so now the question becomes, how far out do we want it to protrude? And that comes down to how much space we have to work with. Ultimately, it has to make it through a 2.7 millimeter diameter pinch clip, or hole. And really what we're looking for, if we consider half of this guy, is that the total radius from the center out plus our dude has to make it through the middle. So however much we're going to cut out of the middle for the pinchy part is however much extra space we get to use off to the side. So it's 2.7. We could sacrifice 1.5 millimeters out of the middle and put 3/4 of a millimeter on either side. And I think that sounds pretty good. So let's do that. We'll make it 1 millimeter thick for rigidity and strength and 0.75 millimeters wide, like that. And on the bottom, we'll give it the same 1 millimeter, but let's double it to 1 thick and 1.5 wide. That way we know that it'll fit through this gap and definitively not through that one. And yeah, that's pretty much going to be that profile. So now we can revolve that dude and that guy about this axis, and I think that looks fine. So we're going to do that, and now we've got these other 2 new bodies. And from here, I'm going to grab this body and that body, and we're going to create a pattern out of these. It's going to be a circular pattern like that, and then from here it's a matter of taking all of those guys and joining them. So we're going to hit the combine modifier, and we're just going to go down 1, 2, 3, 4, 5 and hit join. And they're all part of the case now. So the only thing left that we really have to do is cut off of the top of this guy. So I'm going to make a rectangle off of a center point and another guy. And we know it's going to have to be 1.5 millimeters thick because that's what we banked on with the pinch clips. And then that's plenty high right there. We'll just call that 3.5. And we got that dude. We can finish the sketch. And now what we can do is we can tell Fusion, hey, I want to extrude that guy. I keep flipping that up, but yeah, we're going to extrude those surfaces down, which is going to cut through the pinch clip, and how deep we want to go depends on how much we need it to bend. And I'm just going to eyeball it and say that, I don't know, somewhere in there looks good. So we're going to split the difference, call it -8.5, and boom, there we go. That should work relatively well. So now we have to copy that pinch clip over to the other 3, which is going to be a little interesting, but we have this nice tool that we can split the body, and we can say, hey, I want to split that dude on that plane, and go. And now we've got these other 4 pinch clips that we can go 1, 2, 3, goodbye. That's right. We technically don't want to delete it. So if I come back, can we remove? We can. So, okay. Big note there. When you delete something in Fusion, it's like gone forever, permanent, done. But the problem is you don't really want to do that here because it still exists in the timeline, and it's gonna mess stuff up if we delete things that are already referenced in the timeline, and we don't want to do that. So yeah, although now that I'm looking at it, we accidentally extruded, when we cut into the head of this pinch clip, we accidentally did so through the Raspberry Pi board. So this is actually a really good example where we can roll the timeline back to this operation and edit that specific feature. And we can actually come in here and say, hey, I don't want to extrude those. I only want to extrude the part of the rectangle that's actually inside of the clip. And if we hit OK and play everything forward, fixed. That is like the #1 feature of Fusion 360 to me. Like, no joke. That is such a game changer that one feature alone is why I use the software. On top of the fact that I just find it substantially more intuitive than any other piece of CAD software, but like, yeah, that's just incredible. Not sponsored by them, in case anyone was wondering. Maybe one day. So we can now take this dude, and it's as easy as move, and we can just say create a copy. We know we need to move him 49 millimeters in the Y direction. 49, easy. And then we can grab 1 and 2 and move both of these dudes. Was it 58 millimeters? 58, that way. 5, 8. Nice. And now we can make them all one big happy family again. And 1, 2, 3, 4, 5. Done. Not bad. Not bad at all. Now, looking at this point, it is kind of ridiculous just how tall we made those pinch clips. And I'm kind of regretting that choice now. So we're going to come all the way back to the spot where we extruded the pinch clip, which was somewhere in here. And we can extrude it 1 millimeter less. And attempt to play everything forward. But it didn't like it. So let's roll the timeline back and fix these issues as they crop up. Because when we extruded it this time, we didn't actually hide the Raspberry Pi itself, and so it merged them. And if we do it the right way, everything plays forward just fine. And they are slightly less ridiculous looking now. Still not completely satisfied with them though. So let's edit this one last time. Make sure we hide that guy. Call them 14 millimeters. Hit enter. Throw that back on. That looks pretty good. I am happy with that. That wasn't bad at all. I mean, again, in the end, it really just comes down to intelligently and methodically laying these things out so that later on you can go back and tweak them as you need to, and just having and taking good measurements. If you do that, then kind of just falls into place. So that's where I'm going to leave off for today. Obviously don't want to make this the majority of my content because I really enjoy playing video games and being more artistic and creating stuff. I mean, I do a lot of this kind of day in, day out sort of thing, but on the flip side, like, it's nice and I do enjoy it and I'd like to share it with you guys. So yeah, as always, throw a like on this if you liked the video. If you have feedback for me, better ways I could use Fusion 360, tips as an engineer, if you want to see less of this, if you want to see this but in a slightly different way with more or less detail, let's have a discussion in the comments section over it. So yeah, I'll catch you guys there. Have a good one.